Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2195, indicates that the air-fuel AF sensor signal, sensor 1, is stuck lean. This means that the output voltage from the AF sensor is higher than a specified value, suggesting a potentially abnormal condition in the air-fuel mixture that could affect engine performance, emissions, and overall vehicle functionality. The AF sensor plays a critical role in monitoring the air-fuel mixture, providing necessary feedback to the powertrain control module, PCM, to optimize combustion efficiency. The AF sensor, sensor 1, is usually located in the exhaust stream before the catalytic converter, and is essential for maintaining the ideal air-fuel ratio. If the vehicle was recently out of fuel and stalled, the DTC might have been mistakenly triggered. In that case, simply refueling may clear the DTC. If the issue persists, a thorough diagnosis is required, following a systematic troubleshooting guide. The A-factor sensor, sensor 1, is essential for monitoring the air-fuel mixture coming into the engine. If the sensor's output voltage indicates a value higher than standard specifications, the PCM interprets this as a signal that the air-fuel mixture is too lean, which means that there may not be enough fuel compared to air in the mixture for efficient combustion. The PCM's main function is to manage the engine's operations, including fuel injection, ignition timing, and transmission, and emissions control. Correct placement of this sensor is vital, as it sits in the exhaust pathway where it can accurately assess the condition of the exhaust gases. If this sensor fails or presents erratic signals, it can lead to performance issues or increased emissions. Therefore, understanding the sensor's location and role helps in precise troubleshooting actions. Several factors can lead to the triggering of DTC P2195. One common cause is a dirty or obstructed mass airflow, MAF sensor, or intake air temperature, IAT sensor, which can provide incorrect readings to the PCM, ultimately affecting the AF sensor's output. Another significant possibility is a malfunctioning or defective AF sensor itself, which may not respond correctly, leading to abnormal voltage readings that the PCM recognizes as a fault. Lastly, issues can also stem from the PCM itself, which may not process signals correctly due to internal faults or software issues. Each of these components plays a critical role in maintaining the overall engine performance, and issues with any could lead to an erroneous DTC being logged. When dealing with DTC P2195, several symptoms may become evident during vehicle operation. One of the most noticeable is poor engine performance, often manifesting as a lack of power, rough idling, or stalling, which can affect overall drivability. The air-fuel ratio being skewed too lean may also result in increased emissions, leading to potential failings during emissions testing. Additionally, the check engine light will likely illuminate on the dashboard, alerting the driver to investigate the issue further. Each of these symptoms contributes to the necessity of addressing the DTC as soon as possible to avoid further engine damage or increased repair costs. The first step in troubleshooting DTC P2195 is to perform the confirmation procedure. To begin, start the engine and allow it to run. The next crucial step is to hold the engine speed at 3,000 RPM without any load while the vehicle is in park or neutral. This condition is essential because it allows the engine to reach an operational state where the various sensors, including the AF sensor, can accurately report their readings back to the PCM. As you maintain this RPM, Wait for the radiator fan to activate, which typically indicates that the engine has achieved the necessary operating temperature for the sensors to function correctly. This step helps ensure that any transitory issues that may have triggered the DTC are verified before delving deeper into the specific component checks. The second step in troubleshooting involves inspecting the MAF sensor and IAT sensor for cleanliness. First, remove the MAF IAT sensor to examine its condition closely. Dirt or debris on the sensor can disrupt the airflow readings it provides to the PCM, which could consequently affect the AF sensor performance. It is critical to assess the sensor visually. If you find no obstructions, the sensor is functioning normally, and you can affirm that it is not the source of the DTC. On the other hand, if dirt or debris is present, this confirms there might be a problem within the MAF IAT sensor that needs cleaning or replacement, and addressing this could resolve the DTC. The third troubleshooting step focuses on the AF sensor's installation and connections. Start by inspecting the connections to the AF sensor, sensor 1, carefully. Any loose or improper connections may lead to inaccurate readings. A secure and tight connection ensures that the sensor can transmit accurate data to the PCM without interruption. If you discover issues with the connection, it is essential to rectify them immediately. Should the condition of the connections be satisfactory, yet the DTC remains, it indicates a malfunction in the AF sensor itself, which will require replacement. If loose connections were rectified, but the problem persists, it confirms that the sensor may not be installed correctly and should be reinstalled to ensure it functions as intended. The final troubleshooting step assesses the PCM for potential faults. Before reaching this stage, it is crucial to ensure that all previous component inspections have indicated normal conditions. If those conditions point to no faults, it implies that the PCM may be the root cause of the DTC. The PCM, or Powertrain Control Module, acts as the vehicle's brain, analyzing inputs from various sensors and making adjustments necessary for optimal engine performance. Should it be determined that the PCM is faulty, replacement may be needed to continue vehicle operation. Proper evaluation of these previous components will guide you to ensure you address only the necessary repairs, making it a cost-effective approach. After completing all repairs related to DTC P2195, it's imperative to verify the effectiveness of the repair process. Start by utilizing the Honda Diagnostics System, HDS, to clear the DTC from the vehicle's computer memory. This step will reset the PCM and allow you to monitor the vehicle without previous errors contaminating the data. Next, conduct a test drive under normal operating conditions, paying attention to any irregularities in engine performance. Finally, after driving the vehicle for a short time, check the DTC status again to determine if the code reappears. Successful clearing of the DTC without recurrence indicates that the repairs were effective. To minimize the risk of encountering DTC P2195 or similar issues in the future, implementing a preventive maintenance plan is essential. Regular inspections of the AF sensor and additional related components should be part of routine vehicle checkups. Cleaning the MAF and IAT sensors can prevent buildup that could lead to inaccurate readings, while maintaining a clean air filter ensures that your engine receives optimal airflow. Additionally, scheduling periodic inspections allows for early detection of potential issues, enabling timely repairs before they escalate. By adopting these practices, vehicle efficiency can enhance and costly repairs may be reduced in the long run. In conclusion, understanding the implications of DTC P2195 is essential for maintaining optimal vehicle performance. This particular DTC indicates a lean AF sensor signal, which can significantly affect engine operation and emissions. Adhering to a step-by-step troubleshooting approach enables technicians to accurately diagnose and rectify issues associated with this code. Repairing or replacing the faulty components, such as the AF sensor or MAF IAT sensors, is critical for restoring proper function. Furthermore, preventive maintenance steps are vital for ensuring longevity and reliable performance of the vehicle. By grasping these aspects, you can effectively manage and mitigate potential issues with the air-fuel mixture in your Honda CR-V. Please like and subscribe to the channel. See you next time.